We've got an NMR example here, going from 0 up to 5 in this case. This is delta. This is just your marker here, the standard. And here's the molecule we're working with. We just don't have the structure, okay? And we have the integration of 1 to 6. This is a multiplet. We can't tell exactly how many peaks it has. And this is a doublet, okay? This is just random. All right. So, how do we solve this? Well, notice that the integration, you sum it up, it actually equals 7. So this refers to 1 hydrogen, and this will refer to 6. Okay? Here we have 6 hydrogens that have one single neighbor, which kind of makes sense. This is 1 and 6. And the way to evenly get 6, they have to be all equivalent. They seem to be all equivalent, so it seems like we're working with 2 CH3s here, kind of like that are equivalent, and they're next to a single carbon, because remember, this is the number of neighbors plus 1, so they're next to one neighbor. In this case, we have 1 hydrogen, a 1 from the integration. Okay, so we have 1 hydrogen that is next to a bunch of others, and from the peaks here, they're a little hard to read, so we don't know exactly how many they're next to. But of course, we suspect, since there's only a group of 1 and a group of 6, it'd be something like this. Now notice there's also the iodine here. The iodine is an electronic species. It's going to cause a shift. Okay? Notice these here are next to 2, so they're not that close to the iodine. This is a little high for an alkane, which we expect if it's kind of, sort of close to the iodine. However, it's in general in the normal alkane range. So the iodine definitely has to be over here because this is shifted over to 4. Okay, so expect the iodine to be here. And what I expect, just put the pieces together. We've got the 2 methyl groups attached right here. So it's something like this. And now let's double check our answer to see if this works. So we think the single hydrogen is this peak. If it has 6 neighbors, we add 1 to that, it should give us a 7 peaks, and that's most likely what we're getting here. And then it's close to the iodine, so it's shifted to a higher ppm. Then over here we have 2 CH3s. Those 2 CH3s are all equivalent, and they're next to a single hydrogen. Because they're next to 1, we add 1 to that, and we should get a doublet. And that's exactly what I get. So this is our structure right here, 2-iodo propane.